Hello, everybody. Welcome to eApprentice.net Weekly Office Hours. My name is Derek Goodwin, and I'd like to welcome you. Thank you for showing up this afternoon. It's still afternoon out here on the West Coast, and we do have presenters tonight covering the entire United States. So we're from East Coast to West Coast. So welcome, everybody. Thank you for signing up. I see we have quite a few people out there tonight. Some people I recognize and others I don't. So if you're new to our webinars, let me just give you a quick overview and then we'll go directly into our presentation for today. So we are eApprentice.net and we do online CNC training. And what we do is we build courses similar to what you would see if you took an online college course. And our current courses are very heavily into Mastercam, so CAD/CAM programs, CNC programming using Mastercam. We also have courses in SolidWorks, so I'll just scroll down here and you'll see the different offers we have. We also have a beginning Mastercam in Spanish. So we've got a special presentation tonight. This is our newest course, and this course is based on a book called The Secrets of Fiveaxis Machining, and the book's written by Karlo Apro. And Carlo has built a course, especially for eApprentice.net, based on the book, but the course actually goes a little bit further into the actual CAM applications. Carlo works at CNC Software, the makers of Mastercam, and is now the technical manager in charge of product marketing. And Carlo works very closely with CNC Software to develop especially the higher end, the Multiaxis applications and the Mastercam for SolidWorks, Renishaw probing, and other things. So I'll allow Carlo to talk about that a little bit as he begins his introduction. So that's about it for me today, folks, as far as the commercial. I would like to mention that Carlo's course is available on eApprentice.net, and we're doing a special promotion as we launch this course. The course costs $250. It's an online course, and once you purchase the course, you have access to that information forever. And if you purchase the course this week, we will be including a free copy of Carlo's book, Secrets of Fiveaxis Machining, and that will be a signed copy. Carlo will actually sign the copy for you. So without any further ado, it's time to switch over, and I am going to change the screen, send it over to Carlo, and then we'll begin today's presentation.
Thanks, Eric. The most rewarding part of my job is to connect with users like you and share my passion for multi-axis machining. I travel around the globe to create awareness about our capabilities and also to gather your feedback, because your feedback is the driving force behind our development. Now, this presentation is, like Derek said, based on my book. It's meant to demystify five-axis machining and show that machining is fun. Okay, so most people think about parts like this when they think about five-axis machining. I mean, this is one of the misconceptions, that this is five-axis machining, which it is, but most people don't start here with something complex like this. You can see this movie right now?
Yes, that's working perfectly, Carlo.
Okay. The reality is that people don't start, they would start with something simpler, because starting there would be like drinking from a fire hose. Most people would start with something simpler, like this part here, which if you imagine cutting this part on a 3-axis machine, you realize that you would need multiple fixtures to do this. First, of course, you would turn most of the material off like this. And once that was done, then you could create a fixture like this, a plate with a V-block, and put it on a 4-axis machine and machine it from multiple angles by rotating the fixture. So it's very simple operation, simple contour operation here from this side, and I'm just going to speed it up a little bit here. And then once this side was done, then I can rotate the whole picture and cut the part from the other side. Let's just rotate this to the other side. Again, this is just a simple contour operation, 2D. This we call positioning multi-axis machining. And then we will rotate it once again and cut that. Again, simple contour operations, but the part looks fairly complex. On a 3-axis machine, you would have had multiple fixtures and many chances of making an error. The next step in this evolution is going to 5-axis indexing. What I shown you first was a 4-axis indexing job. This is 5-axis indexing. This is a complex looking part, but it's really a forging, and all the operations are very simple. What we're doing is some facing, contouring, some drilling, but we are attacking this part from many angles using positioning toolpads. This is a dual rotary table, so it can do 5-axis positioning. This is another example of 5-axis positioning work. There is a palette changer there, and then the operation is really just a little facing operation. Then we change the angle, another facing operation. Or here is another example, is a Mystique 1060. It's like a vertical mill lathe. We have two parts, identical parts in different fixtures. In the toolpads, again, are very simplistic, but they are still 5-axis toolpads. A lot of times when you talk to people and ask them if they do 5-axis machining, they mean this, positioning. Now the next step would be continuous 4-axis. In the evolution, again, we are talking about how most people get to 5-axis. It is a 4-axis machine. This is this part is a blower. It looks like a blower for a turbocharger. This is one way you could machine something like this. We have continuous rotary motion as we go around this part. It's a spiral toolpad going down the part. Or second example for 4-axis continuous is this part that has these circular pockets. And here we are machining those circular pockets on a 4-axis horizontal machine. This is just a finishing operation. So once you graduate from 4-axis continuous, you will go into 5-axis combination toolpad, where we would do 5-axis toolpad, but really we would lock one axis to some angle. In this case, we are machining this feature on this. This is an EDM electrode. There's a very small fillet on the bottom of this OD, and we have to machine this whole face here. Now, if you did this on a 3-axis machine, you would need a long, skinny ball nose cutter to cut that fillet. But if you're using a 5-axis machine, and this is really just a dual rotary device on a 3-axis machine, you could use a taper and ball nose cutter to get close, to get into that corner, so you have much better rigidity, much better finish when you're cutting something like this. Again, a toolpad is a spiral toolpad that goes and machines that whole features, that kind of skewed face. And the next step would be a dedicated 5-axis machine like this. This is a Box-O-Matic. This one has a tilting head and a rotary table. And it's in this example, we are cutting a single blade, turbine blade. And we're using one of the features that lets us change the angle of this head. Let me move it up here. When we're cutting on this side, we want to be able to reach this root. And as we going down this turbine blade, we are really just doing a spiral cut on this. We want to change that angle so that we can get to this face. So let me move it up. That is our toolpad, and I'm just going to move it along so you can see how that angle changed. And it's changing gradually as you go into the other side. So this is some people call true 5-axis because it's continuous 5-axis machining, not indexing. And then you can have some advanced features where you can do, say, some trimming. Here, this looks like a motorcycle shield shaped part. And the actual part is just this golden looking part. This whole thing is a fixture. And here we have an ability to trim that and oscillate the tool back and forth so we can get a good tool life out of this. And now we're back to the beginning where we are cutting the impeller on the true 5-axis motion. So this machine has a this is actually a C-axis. This is a vertical machine, even though it looks like horizontal. This is a C-axis. We have an A-axis and XYZ. Everything is moving at once to give you continuous 5-axis machining here. Now, you may say, I'm making molds. Why would I use 5-axis machining for that? And if you look at this part, you could probably cut most of this part with 3-axis machining techniques. You can cut this cavity and use a ball nose cutter, do this floor. The challenging part would be this fillet. This fillet is on the next to this wall that is usually 1 or 2 degree draft angle. It's a deep pocket, so you would have to get in again with a skinny ball nose cutter to cut this. If you have a 5-axis machine and you can program 5-axis machine in Mastercam, then you could use a taper end ball nose cutter and tilt it away from that wall. And this is the example that describes or shows what that would look like. So as you can see, we are tilting away. We cut everything 3-axis, cut the walls, cut the floor, but there is material remaining at the bottom of that in that fillet. So we will do some multiple passes that are all parallel to the floor, and they will go down on the wall to blend into that fillet. I realize there may be some delay in this as you're looking at the display. And if you had a mold that was more complex, like this one, there is many more opportunities to use 5-axis machining to get to some of these fillets that are hard to get to. Now this is one of the parts that we cut at CNC Software. We have a full machine shop where we actually test Toolpads, and this is one of those parts that we cut. It's an induction pump, and this just shows the challenges that you're facing when you're cutting 5-axis. Continuous 5-axis. This is one of the more challenging jobs because you not only have to cut perfect cut pattern precisely, you also have to pay attention on controlling the tool, the clearances between the tool and the part and the fixture. We get within 30 thousandths of the part with the holder. Now in Mastercam you have full capability to control all these motions. So you're not colliding, but you get close, because that's our whole trick of getting close but not colliding and creating precise, smooth toolpaths. We also have an addition that runs inside SolidWorks, so we can actually we can use multi-axis toolpaths inside SolidWorks. You're actually firing Mastercam up and running inside SolidWorks. This is one of the examples that we did in SolidWorks for machining multi-axis. This is a landing gear driving this machine. Now, some of the additional controls that you also have in Mastercam, and I'm not going right now, this is an intro, so I won't go into real detail of how to control this, but I just want to create awareness about some of the capabilities. These capabilities actually are stock model awareness. We actually trim the toolpad based on your stock. The part we are cutting here is really just a slot inside the cylinder, but this slot is really deep on the face of the cylinder and really shallow on the back end of that cylinder. So as you can see, the toolpad Mastercam is actually aware of what the stock is, and it's trimming the toolpad. Because otherwise, if we did say multi-depth cuts here, like that's what we're doing, if I just repeated the bottom pattern, 6-7 times, most of this toolpad would be cutting air. Right now, I said only run out so far out of material, so you can reposition and then blend spline between the motions. And we have stock model awareness, which can save you a lot of times. It can save actually over 50-60% of cycle time by just doing this. Another thing that you can do also is we are trimming this part, and let me just show you the actual motion. We're not just trimming it, we're actually going up and down. We're oscillating the tool up and down in order to avoid tool wear in the same spot. And this is really, we developed this based on our customer feedback. Customers who are cutting composite materials that are really abrasive on the tool, we found that using this technique you can prolong the tool life greatly. So this is just some additional capability that exists in Fiveaxis. Now some of our customers are cutting other than metal, so wood. These customers cutting marble. As you know, you cannot bend it, so this is how they machine it. And you can see the scale of this machine by just looking at this guy here. This is a 40-inch diameter blade, and the cutting motion looks kind of like this. This is a finish operation on imagine a big bird bath. This is actually like a hot tub sized bird bath. We're using that 40-inch blade and going around, staying normal to the surface, and we are changing that angle so that the blade can actually reach the bottom of this. So we are continuously changing the angle of the blade to make sure that there is no collisions between the blade and the part. The roughing toolpath actually is just zigzag toolpath going 45 degrees through the part and then rotating another 45, and then they blast this out with high pressure coolant. But this was a finishing toolpath. This is the Mastercam for SolidWorks part that we just did. It gives you an ability to do turning and milling in the same environment. So this is Mastercam running inside Mastercam for SolidWorks. Inside SolidWorks, we create a turning toolpath, and you can see in this one we have a DZ coordinate system because that's the plate. And then when you go to milling toolpaths, notice how this changes your coordinate system to reflect the toolpath creation. There's a bunch of toolpaths here, and actually I will just show the resulting toolpath in our simulator. We will spend in future presentations spend some time on this whole simulation of how to use this simulation, how to build a machine from scratch. That will be one of the presentations in the course, and we will spend time on techniques, controls that you can use in Mastercam to drive machines like this. So I will just let this kind of go through to the motion here. Actually, this particular toolpath is using stock recognition, And once this roughing is done, we'll come in with a different tool, and we will have to cut this cylinder here, just this cylinder, which is eccentric, with this tool. And my actual toolpad is a zigzag toolpad that starts in the center and it steps out zigzags, maintaining climb cutting. And it's trimmed. The actual toolpad goes right around the cylinder, but I'm using stock recognition, so Mastercam knows what the stock is, and it won't rotate all around that eccentric cylinder when there is no material. It only rotates as much as it has to out here, but once you get closer to the cylinder, there will be material left. So then it will start rotating around right here to give you that tolerability. And this file is really showing all the capabilities, like collisions are, funny here. They are not funny on the machine. The whole idea is that you want to catch them here and correct them before you put it on the machine. And you can use this tool to really double check everything and make sure that you have an efficient toolpad, not just error-free, but efficient toolpad also. Here is that ability I was showing you earlier, where we are changing the angle of that tool gradually. Like we're using this bones cutter to actually finish that eccentric cylinder here on this crankshaft. There's a very small fillet in this corner. That's why we have to use such a small tool. But as we are going around in a spiral cut pattern around this cylinder, we are changing the side tilt angle of that cutter gradually to make sure that we avoid any collisions on the other side of this part. Let's just move it along right here. We already changed the angle so that we can get close to any part of that part. Okay, let me go to the next slide here. This is a question I a lot of times ask students when I'm teaching Fiveaxis machining. Is what is the first step that you do when you get a part? And in 3-axis, the first step is usually people think about, okay, how will I hold this part? You will sit down really and think about things, right? You will meditate, saying, okay, this is what my part looks like, and you will have a mental image of your part, or you will be looking at it on a drawing or in a CAD system. You will take into consideration what is your material you're starting with, what kind of fixtures you're going to use, what tools will you use, what kind of machine do you have available, what equipment, and how you will measure this. This is usually what people do who are used to do 3-axis machining. You will think about what kind of machine you will, what kind of programming method will you use. This is one of the old ones, like a flex writer where I started. So when you go to a 5-axis machine, there is a slight change in thinking. Mostly about the fixture. Fixture shouldn't be the first thing you think about, because that may paint yourself into a corner. The typical 5-axis flow for something like this, you're cutting this motorcycle shield part, and say I'm putting this on this machine. First of all, it's very important to know where I will put this on the machine, because the farther you put it from the center, the more it will have to rotate. So most 5-axis programmers will create a toolpath, and let's not get into details how at this point, and backplot that and say, okay, here's my toolpath. I'm doing this trimming toolpath, doing oscillation, and this is what I look in backplot, and I like everything. It's a toolpath is looking good. I have the oscillation. Everything is great. Instead of designing a fixture now, I will put it in a machine, on a virtual machine, and on a virtual machine I have this amazing ability that I don't have on a real machine. is I can levitate my part. I can just put it in space and run it, and as you can see, there is problems here. There's a problem with a collision. Now remember, when I ran this in Mastercam, there was no collision. So I have to make some decisions. Okay, this is not a programming error, it's a positioning error. If I move this part closer to the edge of the table, I may avoid a collision. So let's do that. I will design a fixture, even though it's a little premature, and say, okay, let's see. I move it closer to the edge. There's my fixture. Run it to the simulation, and there is no collision. So that's great, but I'm getting right here, I have an over travel, and the simulator would tell me that you have an over travel on your z-axis. So the way I design this fixture is so that I can rotate the top part of the fixture, and by rotating that I get a better place on the machine, so I'm in the optimum place in my work envelope to cut this part. So this would be the typical flow that most Fiveaxis programmers would go through. And to get that control, these are the main controls that you would use. Cut pattern, and this is already familiar with everybody who's machining, because even a straight line is a cut pattern, a circle is a cut pattern, a zigzag, that's all cut patterns. In Fiveaxis, there is this new concept, tool-axis control, because you have to tilt your tool axis in ways as you follow the cut pattern, and usually so that you can avoid collisions. Then we have tooltip control and collision avoidance. And this will be really the next presentation that we will be doing is all these controls of Mastercam, where they are, how are they used, what kind of controls they are. So at this point, this is really my presentation. Welcome any questions.
Hey, Carlo. Thank you for that presentation. That's really a fantastic introduction and overview of the Fiveaxis process. I like the way you're really talking about when to design a fixture. So these are things that you need to consider beyond just how to program the part in Mastercam, which is complicated enough. So, hey, everybody out there, Carlo actually wrote the book, literally, on Fiveaxis. So if you have a question or a comment, or you'd like to speak with Carlo live, now's your chance. So I've got some questions lining up, Carlo. I'm going to, first of all, just, let's see. Okay, I had one person had his hand up for almost the whole presentation, but looks like we took too long. He stepped out, so we'll talk to him soon. I'm going to get to questions in a minute, but let me just go to Guy. Guy also has his hand up, and let's see if we can get a question from Guy. Hey, Guy, you're on mic. How are you?
Yeah, I'm good, thanks. Yeah, that was very interesting. Do you have a syllabus prepared that you could show us right now? What's going to go into the Fiveaxis course? I assume the course is written, and it'd be nice to kind of see what the layout is.
I see. Well, I don't have a prepared syllabus handy. I could flip back to my screen and show you the page. Why don't I do that? And Carlo, I may flip back to your screen in a minute. So let's see. Go back to my screen. And if you look on the website there, Guy, first you look at the home page, and then right now, we have Carlo's course lined up.
Right.
And if you click on the Learn More button here, and I already have that page up, as far as a written syllabus, this is about as much of the actual text that I have as far as explaining to you the different sections in the course. So section 1 is the Mystique of Fiveaxis, is basically the presentation that Carlo has just given you, which is an overview. And the course materials themselves, they're different in different courses, and I know you've taken other courses with me. In this case, it's a PowerPoint presentation. I mean, it's basically exactly what you have just viewed with Carlo, and then he goes deeper into other areas. So Carlo goes a little later into controlling the 5-axis machines.
Will this actually introduce us to using Mastercam as a 5-axis or a multi-axis toolpath generator?
Well, I'll let Carlo, yeah, go ahead, Carlo. I'll let you answer that.
Yes, the first presentation is really controlling 5-axis machines with Mastercam, because my book is really a general overview of similar concepts that everybody uses in the industry, and it was concentrating on the gray area that machine builders and CAD/CAM systems in general are not covering, like how to connect the two, how to set up a 5-axis machine so that it's most efficient for machining parts.
Right.
What are the considerations? So that was the book, but my course will actually dwell into the controls in Mastercam, even custom applications like port and blade expert, machine simulation, how to use it, and I will go to build a complete machine from scratch, and this could be used as a template of building your own machine.
Okay, so, I think I have access to the full capabilities of the Mastercam products, and I would be very much interested in knowing the details on how to actually generate 5-axis toolpaths for a specific machine. I have your book, and I have read it, and it's good. It's good. But definitely there needs to be more specific, as you said, more specific information about particular computer-aided machining software.
Right, and like I was, the book was staying away from any particular CAD/CAM system or any particular CNC machine by design, because that way it doesn't go out of style. You know what I mean? And the concepts stay the same.
I understand completely. It makes perfect sense.
Yeah, as soon as you go, like even this course, I'm going to controlling 5-axis machines. It's in version 6 of Mastercam. Next version, that will be already obsolete. I mean, it will be very much similar, but not the same. So it has to be updated all the time. As soon as you go specific, it has to be updated.
Yeah, well, it would be nice to have a just something, maybe just sort of a generic machine like with the trunnion carrier. That seems to be about the most generic you can get. It's a regular 3-axis machine with two more axes added. And it can be added simply just by putting a trunnion on a mill.
Yes, and we will go through every one of these. I mean, we have 17 machines that represent most of the most common machine types out there. So we will build one of those, and it will be a dual rotary that we build.
Okay, great. Thank you.
All right. Great. Thanks for the question, Guy. And I'll just point out on the screen here, we also have Jay's 5-axis course. If you're looking, Carlo's course is at a high level and gives you, I would say, more of a depth of understanding, and I would certainly recommend that you take Carlo's course first. But once you already have a general understanding of 5-axis, and if you want to simply learn, click by click how to program a part in Mastercam, Jay's course does 6 different Mastercam projects, Mastercam's 5-axis projects. So if you want the specific Mastercam course, that's Jay's course, and I have that visible on my screen now.
Yeah,
so
it's a very, very nice course.
Thank you very much. I appreciate it.
No, and there's Jay is online. I should have noticed. Staff is up to 5 now. Hey Jay, thanks for jumping in and helping us here. I should mention everybody. We have several of our instructors online tonight. We have Carlo, of course, doing the presentation. We also have Jay Kramer, whose course is visible at the moment. And I'll get back to questions in 1 second. They're coming in, but I may as well finish my plugs while I'm here. We also have Michael Witten out there online tonight. We have all these panelists. Usually, we have most of them on a weekly basis here to answer your questions. So I'll go back to questions here. I was just going to quickly go back and give Mike's class a plug, which is SolidWorks for CNC programmers, where we design a horizontal tombstone fixture in SolidWorks, and we completely detail it out with full drawings, exploded views, all that good stuff. And I'd like to also give a quick mention to Micah, who's also helping us on staff tonight. And Micah is our staff writer and video producer and editor. And most of you or I shouldn't say most of you, but a lot of you who show up every week are very familiar with Micah, as he does a lot of our presentations here on eApprentice. So enough for the plugs. Let's get back to the questions. So I've got a question coming in from Justin. Carlo, do you have a library of machines that you use for the visual verification, or do we send you sizes, etc.? Just want to make sure it would be accurate.
There is 17 machines installed with Mastercam since X5, and they are designed to be a template to build your own machines. We didn't call them a Haas and a Mori and a Nakuma because we didn't want to discriminate between machine builders. Instead, we call them, it's a dual rotary trunnion or a head table or a table machine. The idea is that you can take any of those machines and turn them into your own machine. Now, building your own machine would need, you would need to model your machine if you wanted your exact machine. And we would help you assemble it. Now, during my course, I will go through building a machine from scratch, not even taking one of these template machines, but going from scratch. Most people who took that, my feedback from them is, oh, this looks so much easier. And once they go through this course, they are able to build their own machines. So I hope that answers your question.
Right.
We do have a library of
That's
machines.
huge. If people think about that, that's a huge option for you to show that, because that right there can take care of a lot of issues for a lot of people, and there's not many places you're going to get that. So that you're offering that, Carlo, from my view, I didn't know that. That should be a big deal to a lot of people just to even see that part, because of, like you said, how Mastercam is translating and where it's going from here. I caught the last note of what you were talking about with new releases coming out and some of the modifications and changes as like you, I'm testing and working with it. Yeah, I can see this. I see a big change in future.
I go through it click by click. So, and the thing is that all this is recorded, so you can watch it as many times as you like, and build your own machine. And I'm confident that once you see that, you'll be able to build your own machine.
Exactly. So one complete class in the Secrets of 5-Axis course is dedicated, Justin, to modeling up and creating your own machine in Mastercam to use for machine simulation. So thank you for the question, Justin, and go ahead and ask a follow-up question if you have a follow-up on that. We'll look for that, and we'll move on for the moment. Kurt has a question. When might we expect to see transformed tool paths to work in machine simulation. So a question there about transformed tool paths in machine simulation.
Except,
the station for a few minutes?
sorry? We can
Sorry
expect
about
that. Yeah, in X7. It's already working in X7. It's usually when we release software, it's already a couple of years old. And, you know, we are working on the next version, transform and axis substitution, rotate. That wasn't supported in the simulation. I'm assuming you're running X6 right now. It is supported already in X7. X7 will be released next spring sometime. And don't ask me exact date.
Fantastic. Okay, Kurt, hopefully that answers your question. Just a few more months for X7, and we will have Transform fully supported in machine simulation. Fantastic. Okay, and go ahead if you have a follow-up on that, Kurt. You can type that in. And let's move over here. I have another question. I'm probably going to pronounce this wrong, but I have a question from Evgeny, and I appreciate it I apologize if I'm not pronouncing your name there correctly. How Mastercam is suitable for 5-axis micromilling and or laser micromachining? Do we have any options for that in Mastercam, Carlo?
That's more of a tolerance question. We don't really discriminate between how big your machine is when it comes to 5-axis. It's really the difference comes in your cut tolerance that you set when you're generating 5-axis toolpad. You have control over the tool axis vector, and I don't want to really go too deep into this, but when you generate 5-axis toolpaths, what you're generating is a bunch of points in space in XYZ, and then you are adding vector lines to every one of those points that represent the orientation of the tool. You can adjust, and most people don't really adjust this, but you can adjust the length of those vector lines based on the size of your part. And our default is 1 inch in inches and 25 millimeters in metric. But if you're working on very small parts, like we have some dental applications, we change that to like 100 tau. If you're working on something even smaller, you would adjust that even smaller. I mean, that's a short, long answer. I hope I answered your question.
Right. That sounds like the right answer to me. So, Evgeny, feel free to type in a follow-up question there if you would like to go further on that. And just sticking with that question for a minute, as far as a laser, so the micromachining, we would work with tolerancing. How, as far as laser operation there, Carlo, I imagine the rest of the 5-axis would fall under a post-processor. So would there be an application for a laser? Would the laser head just be controlled within its own software?
Well, we do drive lasers, and that really depends on what you're doing with that laser. Like our application is mostly for laser cutting. It's not so much for changing focus and depth, like if you're doing like etching with a laser or bucketing, like, and that's what I think maybe he is asking when he's talking about micro machining. Our application is really for cutting, laser cutting, and we actually have one of the 17 machines that are coming with Mastercam is a laser. It's a 5-axis head laser, Mitsubishi laser.
Right.
But we don't have like an etching application. We handle the tool app as if it was a mill, and we did some special applications for plasma welding. But all the tricks were really done in the post. In Mastercam, all we did is generate a toolpad, the pattern, and the tool axis control to go along that pattern, and we went with the same depth but when they added special cycles in the post that were actually changing the focal point of this plasma welding application. So
I
that's a
see.
fringe really application there.
Right. Okay, well, thanks for that, Carlo. And Evgeny did follow up. Thanks. It's exactly how I'm using Mastercam. So looks like you got directly to the point of his question there. So
All right.
excellent. Let's see. Next question coming in from Chris. Chris, so the class will go in depth to the toolpaths and all of the toggles. I'll let you run with that, Carlo.
No, it won't go into all the toggles. That's J's course. J really goes into the nuts and bolts of every setting in Mastercam. My course is really about the capabilities of Mastercam. Where are the controls, the main controls for cut barrier, tool axis control, tooltip control, and collision controls. But I don't go into details on every button. You know, it's the idea is not to. I guess the analogy would be, I don't go like if you had a car and go to, okay, this lever here does your windshield wipers. This one is your clutch. This is this. I don't go into that minute detail. It's more about this is how you drive this, and these are the main controls.
Right. So that's exactly right. And so, Chris, I mean, in your case, it may, you may prefer Jay's class. I say that because I recognize your name out there, Chris. Chris Rizzo from eMastercam, and certainly a very experienced machinist programmer.
Mm-hmm.
So, yeah. He probably already has a pretty good concept of what it's all about, but wants to go a little bit deeper. So you can follow up with that.
I'm sorry, I'd like to jump in.
Go ahead,
Chris. Chris has a good amount of knowledge that I've seen over the many years on eMastercam. And Chris, maybe we should talk and see what some of the stuff that you're looking for that you might be missing, and maybe we'll go ahead and put something special together for what you're looking for. Or at least I can answer the questions if you want to email me at j@eapprentice.net, and I will look to see what kind of stuff that you're looking for, where you are at this point. Maybe I can say, okay, yeah, this will cover what you want, and if it doesn't, for any reason, maybe we'll go ahead and compile something different that's missing as a secondary course or something to give you more of what you're looking for too.
Yeah, I second that too. Like I'm, from this course, the way I'm looking at this, this is an exchange between you guys and myself. I'm looking to get something out of this, which is feedback. The more feedback I get, the better I can represent you, because I'm a user. My background is not writing software, is using software, and that's why I'm doing what I'm doing on Mastercam. I'm talking to the guys who develop the software, and then giving them the wish list from our users. So I'm looking at this as a user. As a user, I would like to do this and that. One of the things that we got from these kind of meetings is people were asking can you simplify this stuff? We are not really getting anymore. Can you do this or that? Because we can really do everything. I mean, there is really few parts that we couldn't cut, and I haven't seen one yet.
I agree.
But we get questions about, can you make this simpler? And one of the things that makes things simpler is training. Like if you ask somebody, is it hard to ride a bicycle? They will tell you the answer will be based on if they know how to ride one or not. If you don't know, it could be a frustrating and dangerous endeavor. But if you know, it's very simple, right? So it's really a training can make it simpler, and that's part of the reason I'm doing this, to kind of demystify and help out. I seen you, Chris, on the Mastercam, and I know that you know your stuff. So if there is anything I can help you with, if you run into things, please just contact me and see if I can help.
Exactly. So thanks for the question, Chris, and for everybody out there, jay@eapprentice.net. We haven't got Carlo set up with an eApprentice email yet, but I will do that shortly. But Carlo can always be reached at carlo.apro@mastercam.com. And I will follow up with an email. Everybody on the webinar will get a generic GoToMeeting email, but I'll follow up with everybody else with an additional email where I'll give you a link to this webinar so you can rewatch the presentation and, of course, all the questions and answers. And I will include everybody's contact information in there. And just before I jump onto the next question, sticking with Chris, Chris said, thanks, Jay. Just some of the obscure features that I encounter, so just wondering, some of the more in-depth things there. So I'm sure Jay and Chris will get together on that. And I should probably remind everybody that when we build these courses or presentations, really we try to keep everything at a basic level during the presentation, because we find that the actual learning takes place when we start answering questions. So your questions help drive the context and make the experience better for everybody. It's hard to cover every detail in any particular piece of training, but when people ask the right questions, it's actually then becomes very easy to cover the details. So questions are key, and as Carlo mentioned, feedback is key to all of us in the content that we're developing. So I'll move on to the next question. One more question that was also from Chris before I jump off, and I believe Carlo had already answered that. So Carlo, correct me if I'm wrong, did you say that axis substitution would be supported in machine simulation in X7?
Yes.
Yes, excellent. Okay, so axis substitution and transform toolpaths will be
transform and rotate.
Transform and rotate. Excellent.
That should be in our new beta release, correct, Carlo?
Yes.
Yeah. Perfect. Okay.
Can I go off topic for 2 seconds?
Can you go?
I'm sorry?
I'm sorry, Jay. As moderator here, I cannot let you go off topic for even 2 seconds.
Okay.
I kid you. Go ahead, Jay. Nobody's ever been able to stop you going off topic yet.
This is really to a point. Is the only off topic is that I've got Carlos on the phone, and I just had my wife texting me, and she says, "Hi, Carlo."
Thank you. Yeah, awesome.
Excellent. Good stuff. Okay, let's move on. Let's see where we're going here. I have a question from Brad. Okay, do you detail the sequence of selecting surfaces and how to control the depth of cuts? So that would be for Carlo as far as in Carlo's particular course. How would you answer that, Carlo?
No, I don't go into that much detail. I mean, I have a Fiveaxis training course that I developed over years, many years. That is dealing with that kind of detail, but this is not that. And I'm playing with the idea. I mean, Derek and I have been talking. We are really right now trying to fill out the need of what people are interested in, and that could be, we could make that available. But the challenge with that is that's normally a 3-day course, and there is 20 hands-on sample files or training sessions that you go through. There's a PowerPoint that leads you through everything. But that material by itself is not helpful until you kind of get introduced. This is how you use this. So there is a way to do this quicker than, in 3 days. And then it's one of these things that I ran this course in 5 days with hands-on machining in the last day. I ran this course in 3 days with again with custom support, you can bring your files and I can help you with those files. And we are thinking of how to answer this need. I mean, we may be open to something where you can send us files and we can go through those files on an individual basis. There is logistical, challenges there because there is a lot of people have proprietary files that you cannot share, especially cannot share over a webinar. So these are the things that we have to figure out. And again, Jay goes to the nuts and bolts, as I said before. I've seen his training, and it's very comprehensive, and he's way more articulate than I am. So he goes into finite detail. Again, I'm open to suggestions about if you need help with files or with parts you want to cut, want to do one-on-one, and we make it available somehow.
Right. So good. Thank you for that question, Brad, and I'll do your follow-up here in a moment. So I would agree. As Carlo mentioned, when we're talking about the detail and the sequence of selecting surfaces and how to control the depth of cuts, that is certainly covered in Jay's course. Jay's course, basically Jay takes 6 different projects and just delves into the nuts and bolts. Here's how you program this part in Mastercam from the beginning, setting up stock and right through to applying all the tool paths. So we will follow up with you on that, Brad, and see if we can help you. And just your follow-up to that was, I have the need to program eccentric surfaces and holes for the petroleum industry, and where should I look for that information? So you're in the right place, Brad. We'll contact you and we'll see how we can help. So look for that. Let's keep it going here. Let's see. Todd Mann has a question. Sorry I got in late. You may have covered this, but with the DMG and the Siemens control, with the Triori and Cycle 800 command, do you need to position the part on the machine as it is located in Mastercam?
The short answer is no. I mean, the Triori is dynamic picture offset on that Siemens 840D, and in general, most more modern machines have an ability to track the part. You don't have to have it exactly in the same place in Mastercam as it is on the machine. Which is a good thing because, like if you don't precisely indicate the part to match Mastercam's position, that could be big errors on the part. Now, if you don't have that capability, like you have a Haas that doesn't have that option, then you must part in a exact same place relative to machine rotary 0 point. That's a long answer.
No.
I'm not going to go.
Yeah, perfect. I think we got it. So
it's
thanks.
Actually funny you guys brought up the Haas one.
I'm sorry, Jay. Go ahead.
Oops. It's kind of you guys brought in the Haas thought. Actually, is I've been doing some turnkey stuff with the local Haas factory outlet out in this area. There actually is, we just delivered. I'm actually at a college right now, and the students are starting to come in the room, so I'm going to have to jump here in a minute. But with our new implementation of our new Haas with the trunnion, I just was informed that they are working and should be starting to release some of these newer machines, Haas 5-axis machines with that technology, with the tracking. That's a huge deal right now, I have to agree.
Exactly. And there is 2 types of tracking. When you're talking about tracking, and again, this is a longer answer, that there is one is the dynamic picture offset, which is really just positioning toolpaths. Mm-hmm. When you go in the continuous 5-axis, that's a different control. Some people call it RTCP control, but that's an ability to track the part in a continuous 5-axis motion, which is much more complex, because for a positioning move in 5-axis, all you do is, you get away with the tool from the part, then you rotate one axis, rotate the other axis, maybe rotate them both at the same time. But the end result is you rotate the part, you lock your brake, and then attack the part, machine it in a 3-axis toolpad, a 3+2 or even a 2D toolpad. When you go in continuous motion cutting in 5-axis, you have to make sure that the two rotaries are synchronized properly, so that one doesn't arrive earlier to its end position as the other one. Again, I go into this in more detail about controlling 5-axis machines, or why this is important, but I just wanted to say right now there's two kinds, and Haas, we have actually at CNC, we have 2 Haas machines right now. We have machines on rotation, and we actually work with Haas on helping them develop this technology that tracks the part.
Right, excellent.
I was going to say, he's giving away all the secrets of the book right now.
That's why we're here, guys.
I know those details are in this book, and then on these courses, he talks about these things and explains those things. So he's giving away the book for free. Oh my God!
Yeah, but if you want the signed copy, you've got to buy a course. So it all works out.
Very much. Gentlemen, I'm sorry, but I'm going to have to jump. I have students waiting for me. I hope everybody has a great day. Thank you for letting me come in for 2 seconds and shake the cage. I'm going to unshake the cage and run out.
All right, Jay. Thanks for checking in.
Jay.
Thank you. Take care.
Bye-bye.
Bye now. So we have a few other comments. Chris is also teaching a class. Chris has jumped off. And Todd followed up that he does understand. So I have some other questions. I have a lot of people saying thank you, and rather than go through them all, I'm just going to say thank you to everybody. We appreciate your time in being here.
Yes, we do. Yeah.
We do. We realize this is a two-way street, and you're spending your afternoon or your evening here, and we appreciate it. As a moderator, I'm 10 minutes over my time slot now, so I am going to close this down. I've got a few people asking, will this be on a video? So yes, we will post this webinar up on YouTube, and I will send a link to everybody who's on the webinar and make sure that you have access to this. So you get to see the presentation, and you get to listen to all of the questions and answers, and all the support that's been given out so far. So we really appreciate it, guys. And Carlo, I'd just like to thank you particularly. This is a fantastic presentation. I know it's getting late out there on the East Coast, and we really do appreciate you spending the time with us and helping explain these concepts. It's extremely important.
It's a pleasure, and like I said, I'm looking for feedback. Please email me if you have any questions, and I'll do my best to answer any
Perfect. So I will send a follow-up email to everybody, including the link, and I will include the contact information for everybody who is on the course. So again, thank you. I got a lot of people signing off now saying thanks. And thank you. We do appreciate it. So thank you to Jay, who has jumped off now, but thanks, Jay, for being here. Thank you to Mike Witten. I unfortunately kept Mike and Micah's microphones off through the entire presentation, but I'm sure they would have private messaged me if they wanted to jump in. So thanks, guys, for being here. And again, I could go through the questions. It's just thanks, 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 thanks. A lot of people really appreciate you taking the time to be here, Carlo. So with that, thank you, everybody. We're signing out. We will be back next Wednesday at 12 o'clock noon Pacific time. Thanks again, Carlo, and everybody. We'll see you next time.